Hi, welcome to another session of Circuits and Networks. Since we are dealing with gate related problems, so we'll see problems and solutions on unknown resistance calculations, source voltage, current, and power under class 4. So, typical problems I have selected which have repeated in our previous gate exams, especially in electrical engineering. Out of this first question, you can see in figure uh, 1, you can see the value of resistor is given as 25 plus I by 2. So here the resistance value is given as 25 plus I by 2 ohms. So that is the catch of this particular problem. Where I is the current in amperes, the current I is dash. So this is what it is framed in gate 2014 under set 1 paper. So typical problem this is, if at all you observe, it's a simple KVL analysis. So I'm going to apply KVL to this closed circuit like this. So you have minus 300, you have current I which is flowing in resistance, and that resistance value is given as 25 plus I by 2. So I'm taking instead of R as this value and I'm equating to 0 because the algebraic sum of the voltages in a closed circuit is equal to 0. This is what I have framed from the given problem. Now I'll multiply this I with the inner components. So I'll get I square by 2 plus 25I minus 300 equal to 0. In fact, this equation can be further framed as I square plus 50I minus 600 equal to 0. So it's a kind of quadratic equation. So I'm going to get the roots of this particular equation as I1 and I2, which is equal to minus b plus or minus under root of b square minus 4ac by 2 into a. So here you can see instead of a we have 1, instead of b we have 50, and instead of c we have 600, and you have minus over here. So that is why this becomes minus 50 plus or minus under root of 50 square minus of minus plus 4 into uh, 600 by 2, which will give you the value as 10 amperes comma minus 60 amperes. So it's a gate related problem and we need to concentrate only on the positive amplitudes. So here the value of current would be 10 amperes. So you can see simple problem, but the question how typical it is twisted, that is how the gate pattern would be. Instead, I would be saying this is a easy kind of question or problem which is asked in gate 2014. Similar questions they were asked in 1990s and 1996. I will see will see some of the problems where these kind of questions were frequently asked in our past. So let us go with the next problem. In the figure, the value of the source voltage. So gate 2004 problem which was asked for 2 marks. Here you can see we have a T network supported by 1 ampere and we have an unknown voltage source which is delivering 2 amperes of current. So we need to find out what is the actual value of this source voltage. A very interesting problem. Since we have two loops and one node common, so I'm going to apply KCL at particular node V so that I can get one line solution. So P and Q are the references where the source voltage is asked, and we need to remember that 2 amperes is flowing or it is getting delivered from this source voltage. And what is that source voltage we need to find? My interest is to find out V. Once I'm going to get the value of V, it will be easy for me to find out the value of Vs. How you see, I have applied KCL over here. So at this node, 1 ampere is incoming. So minus 1 ampere plus V by 6 is the another branch current over here. And you have minus 2 amperes which is coming towards V, that is equivalent to 0. With that, we'll get the value of voltage. V is equal to 18 volts. How? V by 6 is equal to 3 and V equal to 3 into 6 becomes 18 volts. Now we know what is the value of V. Also you need to concentrate on the problem, the direction of the current. 2 amperes is getting delivered from source voltage Vs. So I can write this branch current as Vs minus V divided by 6 is equal to 2 amperes. Like this. Vs minus V by 6 is equal to 2 amperes. Now we know what is the value of V. We know that the value of V is 18 volts. So therefore, Vs would be equivalent to this 6 into 2 becomes 12 plus, already we know that the V value is 18. So 12 plus 18 equal to 30 volts. So this is another way of asking the unknown parameters from the given data. So you should be very quick in observing what is the data given in the problem. Fine. Let us go with the next numerical. In question 3, the value of resistor R is. So this is framed in gate 2003 under 2 marks. The values of R are given as option as 10 ohms, 18 ohms, 24 ohms and 12 ohms. So how to solve this problem? Also the catch, it is given in the problem, that is the 10 amperes, it is delivered by 100 volts. So I'm identifying V1 as 100 volts. Why V1 as 100 volts? Because it's a node point which is connected directly from this node to the reference node. So that entire branch is carrying a voltage as 100 volts. That's why V1 is equal to 100 volts. If at all you observe, V2 on the opposite side, it is 40 volts. So as I told you, by looking into the problem, certain data will be available. So you have to observe the question as well as the figure carefully so that the data can be easily derived from the given problem. So here V1 is 100 volts, V2 is 40 volts, and current delivered by 100 volts is 10 amperes. Fine. Applying KCL at node V, because I know what is V1, I know what is V2, but I don't know what is V. So this is at T junction. So I'm going to apply KCL at this particular node V. So V, assuming a 2-bit higher potential, V minus V1 by 14 is one branch current, V by 2 is another branch current, and V minus V2 by 1 is another branch current, which is equal to 0, thereby satisfying the KCL, that is the algebraic sum of the currents at particular node is equal to 0. With this, I'll take V common, it becomes 1 by 14. You have V by 1 plus 1 by 2, so it becomes 1 plus 1 by 2 as 3 by 2. That is the value of V taken outside. And the constants on the opposite side, constants we have V1 equal to 100, 100 by 14 on the opposite side. And you have V2 which is 40 on the opposite side. So please get the value of V with the simple mathematics, that is as 30 volts. I hope this probable LCM will give you the final answer as V equal to 30 volts. Now once we know what is V, let us find out how we are going to get the value of R. So we need to observe that 10 amperes is flowing into node V1, thereby I1 is the current which is coming out from this particular node, and that current I1 would be from the direction V1 to V divided by 14. So I'll write V1 minus V by 14 equal to I1. I hope you understood how I framed the branch current I1 here. Fine. Let us find out what is the value of I1. Because I know what is V1, what is V. We have just find out the value of V. And divided by 14 will give you the value of I1, which is equal to 5 amperes. That's good. Why? 10 amperes is incoming. I1 is outgoing, which we have obtained a value as 5 amperes. Now, it is very easy for us to obtain the value of current which is flowing in R. Why? 10 is incoming, I1 5 is outgoing, so naturally I2 would be equivalent to 5 amperes. This is an important point over here. Now once we get the value of I2 as 5 amperes, and we need to also observe that I2 is nothing but V1 minus V2 by R, that is a branch current. So 100 minus 40 by R equal to 5 amperes, right? So I'll get the value of R, which is nothing but 100 minus 40 is 60 divided by 5 equal to 12 ohms. So option D is the right answer. So this is how 2 marks problems are framed. under the unknown parameters. So you can see this is a similar problem what we have seen in our previous classes, right? Now in figure 4, and in the problem 4, we have a 10 volts battery with an initial internal resistance of 1 ohm is connected across a nonlinear load whose VI characteristics is given by 7I equal to V square plus 2V. The current delivered by the battery is dash amperes. So as I told you, the questions which were framed after year 2000s were quite similar to the questions which were framed before 2000. So it's a GATE 1997 problem where you can see the question is twisted in multiple ways. You have a nonlinear load whose voltage is V, and you have 10 volts connected in series with 1 ohm delivering a current I. We need to find out what is the value of I. So for that, let us take the VI characteristics from the given problem. It is given as 7I equal to V square plus 2V. Let us frame this equation as 1. Okay. Now, once you apply KVL to this closed loop, we are going to get minus 10 plus 1 into I plus V equal to 0. Isn't that simple? From this, I'll get the equation in terms of I and V as I equal to 10 minus V. So these two equations we can frame from the given data. Once we are done with these two equations, I'll substitute equation 2 in equation 1. So I'm going to substitute this equation I equal to 10 minus V in equation 1. So it becomes 7 into 10 minus V equal to V square plus 2V. Thereby, I'm going to get a quadratic equation as V square plus 9V minus 70 equal to 0. Let us find out the roots of this equation. So I'll get the roots of this equation as minus b plus or minus under root of b square minus 4ac by 2 into a. Fortunately, the value of a is 1, b is 9, and c is 70. Since you have minus over here, we got plus over here. In fact, these roots leads to minus 9 plus or minus 19 by 2, which will give you the value as 5 volts comma minus 14 volts. Like we have seen in the previous problem, we are going to select only the positive value of voltage, that is 5 volts. Okay, when 5 volts is selected, we know that from equation 2, I is equal to 10 minus V, which is 5, which is equal to 5 amperes. Hence, the answer for this particular solution is 5 amperes. Now, in our next problem, quite similar to the previous problem, please observe that it's a question as in GATE 1996, it was for 1 mark. So you can see when the question was framed for GATE after 2000, that is 2015, the question was much more simpler than the question which was framed in 1999, 1997 and 1996. So it's a 1 mark problem. You can see in this X is an element which always absorbs power. During a particle calculation, it sets up a current of 1 ampere in the direction shown. So here the direction of the current is shown in anti-clockwise and absorbs a power Px. So it absorbs a power Px. It is possible that X can absorb the same power Px, over here for another current I. So the value of current is what? Here the options are given as 3 minus under root 14 amperes, 3 plus under root 14 amperes, 5 amperes, and D option is none. So from looking into the options of A and B, from our previous two problems, we have seen that we have formed a quadratic equation, and from the quadratic equation we were trying to find out the roots. So as of a guess, if at all you want to make a guess, one may go with the wrong option, that option A is the right answer or option B is the right answer. But before cross-checking that, let us analyze the entire circuit what is given to us. You can see here minus 6 volts, positive over here, negative over here it is given here, and the current direction is anti-clockwise. So if at all I am going to frame the powers developed by these given data, so here the power is P6, here the power is P1, and the power which is asked in the problem, that is Px. So when the current is going to flow in anti-clockwise direction, this is how the directions of the developed voltages drop will be obtained across the parameters given, that is the passive elements. So that is an important catch over here. And for this, I'm going to apply minus P6 plus P1 plus Px equal to 0, such that I can make the value of Px is equal to P6 minus P1. So this is the Px value, and from the given data, that is 1 ampere if at all it is flowing, then power at 6 volts will be I is 1 ampere. So V into I minus, this is 1 ohm, so it becomes I square into R. So what is the catch over here? We are given the value of current as 1 ampere. So I'm going to substitute the value of 1 ampere in this equation. I'll get V equal to 6 into 1 ampere minus I square, that is 1 square into R. R value is 1 ohm. So the net value of power is 5 watts. What is asked in the question? During a particular operation, it sets up a current of 1 ampere in the direction shown and absorbs a power of Px. So the value of Px is 5 watts. Now, from the given option, it is possible that X can absorb the same power Px, that is 5 watts, for another current I. So what is that current I? By looking into the options, let us substitute the value of A and B. Since these two are complex numbers, it won't give you the appropriate result. So let us go with option C. So from given option, if we substitute current I equal to 5 amperes, we get, according to this equation, Px is equal to P6 minus P1. Now instead of 1 ampere, I'll substitute the value as 5 amperes. So 6 into 5 minus 5 square into 1, which will give you the value as 5 watts. Hence, the answer for this particular problem is 5 amperes. So that is what we have seen in our today's class under the quadratic equations that can be framed from the given problem. So we have related the problem which are related, which were asked in GATE 2014. GATE 1997, GATE 1996, you can see these three problems were similar, whereas GATE 2003 and GATE 2004, you can look into the parameter where the source voltage is the unknown parameter and resistor is the unknown parameter. So this is how we solve the problems to get the answer in a very shortcut way. So I hope you like this particular class. Please share among your friends, subscribe to this channel, and please press the bell icon for the future notifications. Bye bye.